So at first we will be recalling. So at first we will be recalling the concept, few terminologies which are related to circle, which you must already know. We will just recall that so that while doing the whole chapter circle and the next chapter, the theorems related to circle, you will not face any problem. Apart from those, we will also discuss the concept or tangents, the lines which are related to circle over here. So let's start. We will be discussing circle. Now, whenever we will take a Can you hear me? Am I audible to both of you?
Yes, ma'am. Now I can hear.
Yes, ma'am.
Yeah. So when we will take a compass and we'll place it at a fixed point, the needle of the compass, suppose here, and we will draw we will make it round, just like we will connect a lot of different points all around it. That's when we get a circle. That's why the definition of the circle says the collection of all points in a plane which are at fixed distance from a fixed point in the plane. So as you can see, the collection of all point in the plane. Let's join all point. These are the collection of all point in a plane. These all point are at fixed distance from this fixed point. This is called fixed point. And the name of this fixed point is center of the circle. Now, the center of the circle will be at equal distance from each and every point on the circle. So, if we are having like this, this is the center, then this center will be this distance, this distance, this distance, this all the distance will be same, and that's called radius of the circle. So this is R, this is R, this is R, this one is R, and this one is also R. All right. Now, whenever we are drawing the circle, we are getting three parts. That means if we are having this circle, this is called the interior part of the circle. This one is called the exterior part of the circle. And if you are taking any point, let's say point P, then this point P is on the circle. So you must understand the difference between interior part, exterior part, and on the circle. This is called point P is on the circle. Okay.
Okay.
Now, whenever we will join 2 points on the circle, let's say this is P and we are having one more point Q. And if we will join them, this is called the chord of the circle. All right. So this chord means which passes through, like any 2 points, when you will join them, you will get a chord. Now there is a special chord in the circle. Suppose we are having a circle and we are having a point P over here and point Q over here. And if the chord is passing through the center O, let's say that here we are having a center O. So if your chord is passing through the center, that chord is having a special name called diameter of the circle. You must know this relation, that diameter is equals to 2 times radius, right? Do you know that?
Yes, ma'am.
So chord PQ is a special chord when it is passing through the center, and the name of this special chord is diameter of the circle. This is the largest chord which we can draw in a circle. Whatever chords now you will draw in this circle, that will be smaller than this diameter. All right. Now, suppose we are having a circle like this and like this. Then here this piece of the circle between two points. And this one is point Q. So the piece of the circle, this one PQ, or here also we can say PQ, these are called the arcs of the circle, arc. These are the arcs of the circle. We draw arc like this one, okay? So here PQ is the arc, two arc where you can see in a circle. One of them is major arc. And the other one is minor arc. Whenever we have to represent minor arc, we can just write PQ. Arc PQ or PQ in general. But when we have to represent the major arc, usually we take one more point R like this, and then we say PRQ. This is the arc. If I'm representing like this, then we can say this is the major arc. Okay, if only PQ is written or arc PQ is written, usually we take it as a minor arc. All right. Now, when we are taking exactly the middle through the diameter, when we are taking two arcs like this arc and this arc of a circle, so here there will be no major and minor, both the arc are of same length. Okay, we already know the length of complete circle. Whenever we are walking around the boundary of the circle, that's called circumference of the circle. That's called circumference of the circle. Whenever we come, just move around the boundary of any shape, you must know in geometry, whenever we are moving around the boundary, that's called perimeter of that shape. And the perimeter for the circle is having a specific name called the circumference of the circle. So if we are moving around the boundary of the circular path, we are completing the one revolution. That means we are covering the circumference of the circle. Circumference is just the another name of perimeter. Okay, for circle, there is a specific name for perimeter. Now, whenever we are having a circle like this, here, if we will draw a chord, let's say chord PQ. So here the region between the chord are called as major. Here, can you see the upper part of the chord and the lower part of the chord? Can you see that? This part and the lower part. Can you see both the part of this chord PQ? The upper region and the lower region? This one is called the segment of the circle. Yes, Jasleen, am I audible? Jasleen, can you please unmute yourself?
Yes, ma'am.
Am I audible? Yes, Madiha?
Yes, ma'am.
Okay. So whenever we are drawing a chord, it is dividing. We are getting two regions over there. That's called, the upper region will be called the major segment. And the downward, this one, since it's smaller, it will be named as minor segment. All right.
Okay, ma'am.
Now the sector of a circle. Sector. So whenever we are having a circle, and if we will draw radius like this radius and this radius, then this part is called the sector of the circle. Now the definition of sector says, the region between arc. Okay, let me check. Okay. So here the definition says the region between arc and its two radii. So you will be having an arc and its two radii, whatever region you are getting like that, that is called the sector of the circle. All right. Again, here we will be having one major sector. And here we will be having one minor sector. Now the next concept is tangent to a circle. Tangent to a circle. This is where this is the concept which is related to this chapter. Yes, before starting tangent, let me tell you one more thing. If we are having a circle and if a line is going through it like this, then what can be said over there? This line, this straight line is not intersecting this circle, right? Can you see it? So we can say the straight line AB is not intersecting our circle. Now, if we are having the another case, just like this one and like this one, then here we can say the straight line AB is intersecting our circle. Okay. And the name of this one is secant of circle. So whenever a straight line, is intersecting our circle, that means that is sectioning our circle. That's why the name is secant of a circle. That means our circle is getting divided in few parts, in two parts. So from there only the name came, that is secant of a circle. What's the meaning of secant of a circle? If a line is cutting the circle, that line is the secant of the circle. All right. Now, what's the meaning of tangent of a circle? So when we are having a circle like this one, there must be a line which will touch one point. Okay. So if the straight line is passing just slightly touching the circle at only one point, that line is called the tangent of a circle. Now, how many tangent we can draw over here? If you will try drawing, suppose this is point P. Okay. Now, if we have to draw tangent at a point P, one of the tangent we can see over here. Okay. Now, if I want to draw another tangent, then I will make a line like this and it will go like this. Let me draw it properly. The line will look like this. Or if you will draw another one, the line will look like this one. If you will, it will look like this one. So as you can see, we can only draw, just a second. Yeah. So as we can see, we can draw only one tangent to one of the point in a circle. Okay. This point P is called the point of contact. So if any point is given, through that point, you can draw one and only one tangent to a circle. Through another point, you can draw another tangent, but with this point at a point P, we can draw only one tangent to this circle. All right.
Okay, ma'am.
And here we can also say tangent is a special case of secant. Again, secant means a line which is cutting the circle, which is touching the circle. So tangent is one of the special case of secant line. Okay.
Okay, ma'am.
And here we can say it's the special case when two end point when both the end point of the chord coincide. What's the meaning of this one? Let me explain. Suppose we are having here one point and here only very slightly close to each other another point is there, and there only we are drawing one line. That is the case when we are getting the tangent. That is one of the special case of secant, because while drawing the secant we usually get 2 points. Here we are getting only 1 point, that is P. So we can say there is a imaginary one more point is there which is very close to P, which is just almost P only. Okay, very close to P. That is where we are getting the tangent line. All right.
Okay, ma'am.
Now, here, common point of tangent and the circle, as we have already discussed over here, is called the point of contact. So here, whenever we are drawing a tangent, here we must have a point of contact where the name is saying all about itself. That is the point of contact of the straight line. Okay, the straight line will touch the straight line will touch the circle, and it will touch the circle at one and only one point. That point is called point of contact. Now the next, there is a one theorem. Let me write it, which says the tangent just let me write it, then I'm coming on the screen. At any point of a circle is perpendicular to the radius through the point of contact. So here, let's understand what exactly the theorem says. Can you see the theorem? Both of you, can you see the theorem?
No, ma'am.
Yeah. So here the theorem says the tangent at any point of the circle is perpendicular to the radius through the point of contact. That's why I was just focusing and explaining what exactly is the meaning of this point of contact. So when we are having a circle and when there is a point of contact through which the tangent we are drawing, suppose we are drawing the tangent through point Q. So this is called the point of contact, like this. So the tangent at any point of contact, at any point of a circle, so tangent at a point Q is perpendicular to the radius. So here if we will drop the radius, here if we will drop the radius like this, then it will be perpendicular to the tangent, perpendicular to the radius through the point of contact. So as you can see, through the radius, as you can see through the radius on the tangent, whenever we will drop, just draw a line, that line will be perpendicular to the tangent. Okay? Or the tangent will be perpendicular to the radius. Radius is perpendicular to the tangent or tangent is perpendicular to the radius is the same thing, right? Because both are
Yes,
making
ma'am.
90 degrees with each other. That's it. So if we are drawing two perpendicular line like this and this, suppose this is line L, this is line M. So we can say L is perpendicular to M, or if you are saying M is perpendicular to L, both are same, right?
Yes, ma'am.
Eventually both are making 90 degrees with each other. That's the meaning. Now let's do few questions from here so that we can just apply all the concept which we have learned. Just a second. Asking one tangent a circle can have. One, unmute yourself. A circle can have how many tangents?
Ma'am, you're lagging.
Yes, Madhya. Now the next one I'm asking. Let me write it. A tangent to a Let me stop sharing. Now I am just asking the question, whatever we have discussed related to that. So the next question can be, a tangent to a circle intersect it in how many points?
2 points.
Yes, Jaslyn?
2 points, ma'am.
Yeah.
2 points.
Tangent will intersect a circle at how many points? 1 point or what?
1 point.
Yeah. It will be one and only 1 point, because we have seen that tangent is just slightly touching the circle at only 1 point, and that point name is point of contact. Now the next one is, a circle can have dash parallel tangent at most. How many parallel tangent a circle can have?
2.
Yes, it will be 2 parallel tangent at most. Now, the next question can be, the common point of a tangent to a circle, and the circle is called, what's the common point where we are drawing the tangent? That point is called?
Point of contact.
Yes, that point name is point of contact. Now the next one is a tangent PQ. Let me write this. So here we are having a tangent PQ at a point P of a circle of radius 5 centimeter meets a line through the center O at a point Q so that OQ is equals to 12 centimeter, length of PQ is equals to, so a tangent PQ at a point P of a circle, let's draw. Can you see? At P,
Yes,
we are
ma'am.
having a tangent. Let's say it's PQ of radius 5 centimeter, meter line through the center O at a point Q. We are having OQ is equals to 12 centimeter. Okay. Radius is already given as 5 centimeter. Can you tell me how to find PQ? Anyone?
Pythagoras theorem.
Yeah, by Pythagoras theorem. We can use Pythagoras theorem over here. So that is, let's find it. The theorem says hypotenuse square is equals to perpendicular square plus base square. That is PQ square is equals to 144 minus 25. That is 9.
119.
And here 1, right? So under root 119, right?
Yes.
Yeah. So this is how we will use the theorem. What we are doing, we are using the theorem. If we will not know that this is a right angle triangle, then how we will apply the Pythagoras theorem, right? Because Pythagoras theorem is applicable only for right angle triangle, that we know already. Okay.
Okay, ma'am.
Okay, let's do the next one. Okay, so let's see the next theorem. This is where we are done with the understanding of, we are already having the understanding of tangent of a circle. Okay, how many tangents are there, how a tangent can be drawn, how many tangent can be drawn, and one theorem also related to tangent, that whenever we are having a tangent and when we will draw radius, that radius must be perpendicular to the tangent. Okay, now the next theorem says the length of tangents the length of tangents drawn from external point to a circle are equal. So if we are having a circle like this, and if we are having an external point from where we are dropping the tangent, so suppose there is an external point P, from here we are drawing a tangent. So this tangent and this tangent. Okay, these two tangent from the external point P to a circle must be equal with each other. All right. So here, if we are having point of contact Q, and here if we are having point of contact R, then here we can say PQ must be equals to RQ. All right. Now one more theorem, let's connect it with previous theorem. So the previous theorem, we were having the concept that when we will draw a line through the radius, it will be perpendicular. Here also, when we will draw a line through the radius, it will be perpendicular. Okay.
Hmm.
So this is what the next theorem says. Okay. Now, on the basis of this theorem only, we will be solving a lot of questions. Let me check the questions. Okay, so only one more exercise is there where we are having few more theorem, and including this theorem, we will be discussing about that exercise in detail in the next class. Today I am keeping it till tangent over here, and your homework, let me write it over here. Your homework will be chapter circle, exercise 10.1 from your textbook, complete exercise, full exercise. Full exercise, you have to do it. 10.1. All right. Yes,
Okay, ma'am.
Jaslene and Madhiha, you have to attempt the full exercise from 10.1.
Okay, ma'am.
Let me show you how you will attempt the test. Yeah, before showing you how you will attempt the test, do you want to ask anything from here, whatever we have discussed, if anything is not clear? Yes,
No,
and yes or
Like,
no?
how
No,
much is the maximum number of tangents drawn for a circle?
you are not audible. Can you say it quite loudly?
What are the max, like, tangents that can be drawn for a circle?
Sorry, I'm not getting. Is it possible to write it in chat box?
Okay, ma'am.
Yeah, please write it. And yes, Madiha, you also, if you are having any doubt, please write it. I'll clear those doubt, because now only you will be having the assessment from this part, the tangent to a circle. Only one tangent. Through a point of contact, we can draw one tangent. If there is a predefined point, like suppose we are having a circle and I'm saying only at this point I need a tangent. So how many tangent you can draw through this point of the circle? So one tangent, only one. But in a circle, in general, a lot of different tangent we can draw. Like suppose we are having a circle, then this is point P, this is point Q, this is point R, this is point S. Through every point you can draw one tangent. But through P, one tangent, but you cannot draw more than one. All right. Through Q, if I'm saying, then you can draw only one tangent. So in general, whenever the question is asking, it is asking about through a point of contact, through one point, how many tangent you can draw. And that time you will answer through one point, we can draw only one tangent in a circle. Okay?
Okay, ma'am.
Okay. Yes. Madiha, if you want to ask anything, please ask.
no, ma'am, I understood.
It's clear. Okay. Okay, now let me show you. Have you noted down the homework? Exercise 10.1 completely, fully. All right.
Yes, ma'am.
Yeah.